Today we're going to do a quick video about a very common scenario, and that's splitting one HL7 feed into multiple feeds. Consider the scenario. We're currently receiving a feed of HL7 ADT messages over TCP/IP from the hospital information system, which goes into our EMR listener on port 31001. Let's say that's this here. This is our core HL7 listener. It receives on port 31001. But now we have a new requirement. We need to duplicate that feed and also deliver the messages out to the radiology department over TCP/IP on port 6600. And we need to also write the HL7 messages out to a folder where they can be imported into a core SQL engine or picked up by some other downstream process. Now the problem is our trading partner, which delivers the ADT messages, either can't or won't create three identical feeds. Now this might be a cost issue. It might be that they charge an exorbitant amount to create feeds for you. It might be a problem on your side with cost or maintenance to get the additional receivers set up. But we're going to work through it here. Now our requirements are that anything that we come up with has to have a very minimal impact on any of the existing interfaces because they're in production. All right, here's our solution. It's in 4 steps. First thing we have to do is we'll switch the EMR listener port from 31001 to port 6101. That's easily done. Come into here, we edit this, and we're going to change it from 31001 to 6101. Is that right? Yeah, done. Next, we're going to use our core HL7 postmaster, and we're going to insert it into the interface by having it listen on port 31001 instead of the EMR. And then in our postmaster, we're going to create 3 different destinations. 2 TCP/IP destinations, one for radiology, one for the EMR, and a Windows folder destination for the core SQL engine. Then all we have to do is restart the EMR listener on that new port and start our new postmaster. And when we're done, the only impact to the current interface is that EMR port switch from 31001 to 6101. And the HIS, TCP/IP sender, which is delivering the ADT messages to us, will have no idea that anything has changed. Now let's watch it work. Here on my screen, I have several things set up to simulate this interface. First, I have a sender. This is going to send to port 31001. That's going to simulate my HIS system sending HL7 ADT messages. I have 100 messages loaded and ready to send. Over here, I have 2 listeners. One listening on port 6600. That's to simulate the radiology. One that is listening on port 6100. That is to simulate the EMR. Then over here is my output folder where files are going to be deposited. And this is my core SQL engine, which is running and is currently looking in that folder for HL7 data files to show up. Now to make all this work, we have to have our postmaster here in the middle doing its business. So here it is. It's designed to run in a private service. I just need to start it. There it is. I'm going to start the service. And now this postmaster should be listening on port 31001. I can go here and test the connection. And it says, yes, there is a listener running. Now to make the magic happen, all I have to do is start sending these messages. And they're going to go really fast. We're going to see them go here. They're going to go into the postmaster. It's going to hold on to them for a second and process them. And then you're going to start seeing them going out into these listeners and into the database engine. Ready? Go. 100 messages are gone. And in each one of these, 100 messages received. Messages going into the database, done. Everything is complete. At this point, the entire process is done. We can go in and look in the database. We can check it. All that's left is to implement this in production by turning on our EMR and turning on our radiology, and it's done. And the sending partner, the HIS system, has no idea that anything has changed. So consider liking this video and subscribing to our channel so we can keep producing content like this. Thank you for listening.